Okay, so going to your type C, so this is the last pair up for your Pythagorean identity. And again, if you recall such equation coming from your Pythagorean identity equations, so this will be the last one. So 1 plus cotangent squared theta is equal to cosecant squared theta. So as you can see here, so it's just being manipulated to look into this format. So gi-transfer lang ang 1 to the other side of the equation. Sorry, kuan peta. Case number 1 pa dita. Okay. So again, I'm recalling. So that's 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so for case number 1, so we need to observe the exponent of the cosecant function, which is n. So cosecant function having the exponent of n. And then it states that it should have an even and positive integer. It should be even and positive integer. So if that's the case, so if your n exponent is even and positive, so we need to factor out cosecant u du. So again, the factored out term will be your probable value for your differential of u. So again, it's just probable value because again, it may be negative du or du over 2, du over 2 or 2 du depending on what we have finalized with our u sub technique. Okay, so again, we need to um, isolate this one for later for u sub, the factored out term, just like your type A, B na mga cases. So the factored out term is most likely the differential u parameter. So after that one, once we have factored out cosecant squared, so notice that you're going to use this formula coming from your Pythagorean identity. So since we factored out cosecant squared and we need to replace cosecant squared with this one, 1 plus cotangent u. So we can say that the cosecant squared u here, kaning akong i-circle, is just an extra cosecant squared u left in the integrand. So for example, we're having cosecant to the power of 6, and then we factored out cosecant squared, so meaning we have cosecant to the power of 4 u. So this is what we are going to replace with this particular term. So meaning there's an extra cosecant squared left in the given integrand. Okay. So again, going back, so n should be positive integer, and then factor out cosecant squared u. So this will be our du parameter. And take note that the derivative of cotangent, so again coming from your derivatives, is negative cosecant squared x. So most likely we're going to deal with these two terms here later in our u sub. And then lastly is we apply your cosecant squared u, transforming it into 1 plus cotangent squared u, or its corresponding identity. So let's go to the first example. So again, writing the guide. So again, n should be even and positive. So next is we factor out cosecant squared u du. So next is we replace cosecant squared u with 1 plus cotangent squared u. So after obtaining these steps, so what is the last step is you use the u sub technique. So 1, 2, 3, and 4. So again, observing the n value, which is the function of cosecant. So it's even and positive. So check na tadya. So next is we need to factor out cosecant squared u du. So we need to get 2 from here. So you have the integral. So again, we need to enclose it with a parenthesis for us to be able to see that we have factored out cosecant squared u du. So cotangent cube of 4x. Then getting squared. So what is left here is also squared. So cosecant squared 4 of x. Then on the right side is cosecant squared 4x dx. So kaya ni. So next is we replace your identity of the cosecant squared u with 1 plus cotangent u. So instead of parentheses, so we go to brackets. So I think you can recall this one in your algebra. So parentheses, brackets, and then I don't know what the last term is. Kanang inanam, siguro na. So muna siyang order sa mga sa mga bracketing. Oh, braces pa ron. I forgot the term. So try looking it up online na lang. So cotangent cube 4x, then 1 minus cotangent squared 4 of x, and then cosecant squared 4 of x dx. So again, your 1 minus cotangent squared 4x came from this term. You replaced it with 1 plus cotangent squared 4 of x. So that's its particular identity. Okay, so next is we distribute. So distribute to the both terms. So now is instead of gonna the square the brackets. So parenthesis na lang ta. So cotangent cube 4 of x minus cotangent, so 3 plus 2, so law of exponent. So to the power of 5, 4x cosecant squared 4x dx. Okay, so let's try to arrange them in descending order according to degree. So we need to put first the higher degree on the left side. So we have negative cotangent to the power of 5, 4 of x, plus cotangent cube 4 of x, cosecant squared 4 of x dx. Kani plus tani plus. Okay, so thank you then. So kani plus tani plus. And then kaning isa is 1 na siya ay negative. Okay, so thank you for that one. Okay, so next is, since we are done with replacing the identity of your cosecant squared 4x, and we have simplified the remaining integrand. So again, this is the remaining integrand. So now we can now use u sub. Sige. Masamang square dan eh. Dili siya 4x squared. Kani pasabot mo kani? Kani. Kuan, di na siya mahilabtan og multiply kay ang angle man na siya sa inyong function. So murag if I try to on the right side, so for example, you have sine theta, so times sine theta. So dili siya kuan sine squared theta squared, so dili siya mao. But the answer is only sine squared because you are only multiplying the function of the trigonometric. Ang trigonometric function na inyo ang gi-multiply, dili ang angle. So mana sine squared theta ra siya. Okay? So next is so pangutana lang mo kay dibito kita sa inyong pangan kay naka-kuan ko, naka-PowerPoint presentation ko. Okay, so again, your factored out term earlier in step number 2 is your candidate for your derivative of u in the u sub technique. So again, since we have cosecant squared 4x as your candidate for, or the probable value for your derivative, so again, if we recall our derivatives, what particular function you're going to have to get cosecant squared na derivative? So that will be cotangent 4 of x. So also take note that your cotangent 4x is present in the given integrand. Okay, so derivative of cotangent 4 of x. So again, du is equal to negative cosecant squared 4 of x times 4 dx. So again, the 4 came from your 4x. Bakay sa inyo ang derivative sa inyo trig function is you need to derive again the angle if there is a coefficient. So simplifying is we have negative 4 cosecant squared 4x dx. So for your value to be the same as the factored out term, so we need to divide by negative 4. So your du term here is negative du over 4 is equal to cosecant squared 4 of x dx. So this one is our term here. Okay, so questions so far? Okay, so wala. So let's proceed. So replacing your values of u in the equation. So what we're going to have is the integral of u to the power of 5 plus u to the 3, then negative du all over 4. So we can factor out negative 1/4 outside the integral symbol. So negative 1/4. And what remains inside your integral equation is a basic na lang, approach to your integral. So du. Okay? So don't forget to apply negative 1/4 upon integrating to both terms. Okay? So integral of u to the power of 5, so that will be negative 1/4, then times u to the power of 5, u to the power of 6 I mean. Okay, 5 plus 1 na siya, all over 6. And then minus 1/4. So that's minus 1/4 because negative 1/4 plus u cubed. So again, integral of u cubed is u to the power of 4 all over 4 plus c. So simplifying your equation, that's negative u to the power of 6 all over 24 minus u to the power of 4 all over 16 plus c. Then again, don't forget to bring back the value of your u parameter for your answer to be fully credited. So that's negative cotangent to the 6 of 4x all over 24 minus cotangent to the power of 4 of 4x all over 16 plus c. So that's the final answer. Okay, so do you have questions? Asa man ang kaning koan? Ah, kani di ba kani? Sige, so balik ta. So let me change the koan lang color okay, para makita ninyo. Sa mga color kanila siguro. Okay, so again, according to case number 1, so first is we need to observe the exponent if it's even for the cosecant function because that's the exponent of n. Cotangent m, then cosecant n u. Okay. So next is we factored out the cosecant squared u. So from 4, we get 2. So this is the factored out term, cosecant squared 4x dx. So we don't have to deal with this because this will be important later for the u sub technique. This factored out term. So factored out term will be used later in u sub technique. So you don't have to kanang you don't have to deal with this term as of the moment. So you'll be dealing with this one once you reach the u sub process na. So looking at your equation, so again, we have factored out cosecant squared outside. So na-split na siya, di ba? Ni-split na siya. So 2, then 2 on the outside. So the rule states that if there's any remaining cosecant squared, that's step number 3. So replace cosecant squared u with 1 plus cotangent u. So that's why mo ni siya kani. So mo ni siya ni tabo. And of course, there's also an importance why we need to replace this particular term with 1 plus cotangent squared u because again our candidate for our derivative is du, your cosecant squared for x is your du. So we need to make sure that all our terms inside your remaining integrand are all cotangent so that we can be able to replace every term in your equation. So as you can see, your u is your cotangent for x. And what happened here is what is left is just u cube, u to the 5 plus u cube. Okay? So murag mo na siya ang kuan. So just try to follow the stated rule in the case so that you won't be confused. So try solving this one again, and what I did here is I just followed what the rule is or the case has stated. So I observed the n value, I factored out cosecant squared u du. Then if there's a remaining cosecant squared u, I replaced it with 1 plus cotangent u. Then after I simplify the remaining integrand, then I use the u sub technique. Okay, so my tip here is whatever you factored out is don't replace it with the identity because again the factored out term will be useful later. So just try to ignore it and focus on the remaining integrand here. So again, once you factored out a certain term, so just deal with the factored term later. Just focus on the remaining integrand. So any more questions before we proceed to the last case? Okay, so I think there's no question. So let's proceed with the last case. Okay, so earlier we determined or we observed the exponent of n. That's the function of the cosecant. So this time is we're going to observe your m parameter, which is the cotangent function. Again, so in case number one, we are focusing on the cosecant function. Now, in case number two, we are now focusing on the cotangent function. So your cotangent should be odd and positive. So next is, so after you determine that your cotangent function has an odd exponent, odd and positive exponent, so we need to factor out. So again, if you factor out something, deal with this later until you reach the u sub technique. So factoring out cosecant u, cotangent u. Again, the factored out term is the probable candidate or the probable value for your derivative of u. So again, if we recall our derivatives, so derivative of cosecant x, so let's use x, is negative cosecant x cotangent x. Okay? So since this one is the derivative for your cosecant x, so most likely this will be our u parameter later. And then of course, upon manipulation, so this will be our du. It could be negative du over 2 or something. So since you're going to achieve this u value later, the cosecant, so that's why we're going to replace your remaining cotangent squared with its corresponding identity of cosecant squared u minus 1. So this means that since we replaced your cotangent u with cosecant squared u minus 1, so you can imagine that what is left in the remaining integrand is all in cosecant function. Okay, so there's no more cotangent function remaining in the in the integrand. So the same as the previous example. So let's try to go back for a while. So again, if we try to observe that the remaining integrand are all in cotangent functions, because again, it will be useful because we need to represent your u with the cotangent function. So here, instead of cotangent, so good. So here, instead of cotangent, so we'll be utilizing your cosecant as your u, because again, the derivative of cosecant is negative cosecant x cotangent x, which is your factored out term from earlier. Okay, so managlibog no? So let's try to solve the problem. Okay, so m. So again, if you write the steps, so m should be odd and then positive. So next is factor out cosecant u cotangent u du. And then lastly is we replace cotangent squared u with cosecant squared u minus 1 and then u sub technique. So I'll go kuan na. Tuning tarong og kuan. So I think um your type B and type C have similar cases. Yeah, ang unique lang is katong type A because ang iyang mga identity nga gamit are different. Okay, so again, if you observe cotangent function, it's odd and positive, so correct na siya. So also, you need to also observe the cosecant function. Okay, basin your cosecant is even also. So looking at your cosecant term, so this one is a fraction. So meaning your cosecant function is in radical terms. So di siya pwede, di ba? You cannot use case number 1. So there are moments that you can either use case number 1 or case number 2. So for example, you have cotangent cube x, then the other one is cosecant to the power of 4x, na, di ba? So this one is case number 1. You can use case number 1. You can also use case number 2. So either of your solution are correct. So if you're going to use case number 1, so that's okay. Then if you're going to use case number 2, that's also okay. But they only differ in the final answer because one is expressed in cosecant. So for example, in case number 1, so all the answers are in terms of cotangent. And then case number 2, all our answers are in terms of cosecant. So you'll observe it later. Okay, so next is we factor out cosecant u cotangent u du. So getting one cotangent from the fifth degree. So what happens is this one becomes cotangent. Let's try to so cotangent to the power of 4x. Then getting 1 from cosecant. So this one is cosecant 1/3 of x. And then cosecant x cotangent x dx. Okay. So again, if you try to multiply this one, so cosecant x times cosecant to the 1/3, this becomes cosecant to the 4/3. So 1/3 plus 1 is 4/3. So again, multiplying cotangent with the cotangent to the power of 4. So it results back to cotangent to the 5th of x. So again, I'll underline this one, the factored out term. So we don't have to deal with this term up until we are done with step number 3. So again, Ayos na siya, pansin na. So ignore this term for now. So we focus on the remaining integrand. So in step number 3, so it states that we need to replace cotangent squared u with cosecant squared u minus 1. Okay, so since this one is to the power of 4, so we need to multiply it twice. So this becomes cosecant squared x minus 1 squared, and then cosecant to the 1/3 x, then again bracket, so that we can fully notice that we have the factored out term on the right side. Cotangent x dx. Okay, so again, para di maglibog, let's underline it again. Na para makita jud ba? So since this one is squared again, so we need to expand the term. So we're going to have cosecant to the 4th of x minus 2 cosecant squared x plus 1, then multiplied by cosecant 1/3 of x, then bracket, then cosecant x cotangent x dx. Okay, so next is we distribute. So again, ignore this one. So distribute to each term so that we can finally simplify the remaining integrand. So cosecant, so 4 plus 1/3. So that's 13 all over 3 of x. So try to solve it on your own, the basic math, minus 2 cosecant 7/3 of x plus cosecant 1/3 of x. So cosecant x cotangent x dx. Okay, so now we are ready to use the u sub technique. So u sub na ta. So u sub na ta. So how do you tell that you are ready for the u sub technique? So looking at your remaining integrand, so if it's already simplified, so what's next is the u sub technique na. So if there's nothing left for you to simplify, so that's the time that you're going to use u sub. So again, what we did was we just follow the steps. So watay gibuhat nga lain na kakulian. Okay, so again, this is our candidate for our du. So let's write du here. So again, if we try to reverse our process, so the derivative of your the derivative is cosecant x cotangent x. So from your derivatives, so we all know that the derivative of cosecant is negative cosecant x cotangent x dx, right? Then since this one is negative and the factored out term is positive, so we divide by -1. So that's negative du is equal to cosecant x cotangent x dx. So instead of this one being du, so this one is negative du. And of course, these are all your u terms. So notice again in our u sub, there's nothing left for us to replace. So every term in your equation is being replaced by the u parameter. So that's what you need to achieve in u sub. So every term should be replaced. Okay, so if we try to simplify this one, so what you will have is integral of u to the power of 13 over 3 minus 2 u to the power of 7 thirds plus u to the power of 1 third, then multiplied by negative du. Okay, so simplifying. So taking negative 1 outside the equation, so that's u to the 13 over 3 minus u to the 7 thirds plus u to the 1 third du. So now we can integrate. So again, don't forget to multiply negative 1 upon integrating each term. Na, butang atong arrow para makita jud. Okay, so for the first one is negative u. So this will become 16 all over 3. Then 16 all over 3. Okay, so ang ano 16 over 3 man siya. So kamo ni ada na, that's basic mathematics, diba? Addition of fraction. So negative, then negative. So this one becomes positive 2 times u to the 10 over 3. 10 over 3 plus minus the minus. So again, that's minus because negative times positive. So this one is u to the 4 thirds all over 4 thirds plus c. Okay. So next is we simplify. So this one is negative 3 u to the 16 all over 3 all over 16. So plus 3 u to the 10 over 3 over 5. So ang ano over 5 naman siya because 2 then 10. So 5 na lang, di ba? Minus 3 u to the 4 thirds all over 4 plus c. So replacing back the value of your u parameter. So this one is negative 3 cosecant 16 all over 3 of x all over 16 plus 3 cosecant 10 thirds of x all over 5 minus 3 cosecant 4 thirds of x all over 4 plus c. Okay, so that's your final answer. Okay, so do you have questions? Hello? Okay, so since you don't have any questions, so I think that's it for today.